let's explore how linear regression can be implemented in Python. Our ultimate goal is to answer key questions such as, to what extent do environmental variables like temperature and humidity influence the risk of wildfires? Let's open a notebook, and first we need to load the data. By clicking on the folder icon on the left, a sidebar appears showing the list of available files. Let's click on the Upload button and select from your local file system the file Algerian forest dataset.csv. This dataset contains information about a set of forest fires recorded in Algeria. Next, we start coding. The first step is to import the modules that we will use in the project. We need the module NumPy imported as NP for vector operations. Next, we use the module Pandas imported as PD to work with datasets. Finally, we will use matplotlib to display the data. To load the dataset, we can use the function readCSV, which reads comma-separated values file. Just make sure that the name of the file matches exactly. The output of this function is stored in a variable named myDataset, which is an instance of the class DataFrame from Pandas. Now, a class is more than just a data type. It defines the attributes, the characteristics that an object can have, but also the method, the actions that we can perform on and with the object. So let's explore our dataset using both attributes and methods. First of all, we want to find the number of rows and columns. We use the attribute of the dataset called shape to find the number of rows and columns. And in this case, we have 59 rows and 4 columns. Next, we use the method head. With the line dataset.head of 5, we display the first 5 rows of the dataset. In this table, each row corresponds to a single fire event, while each column corresponds to a variable associated with this specific event. The temperature, expressed in Celsius degrees, the relative humidity, expressed as a percentage, the build-up index, which represents the total amount of combustible material present in the environment, and the fire weather index, which evaluates the overall risk of fire events. In our context, temperature, humidity, and build-up index can play separately the role of the variable x, while the fire weather index plays the role of the variable y. Now we are ready to implement linear regression. We are going to write a function that takes as inputs the data point organized into arrays. The first one, called x, contains the x coordinates of the points, and the second, named y, contains the corresponding y coordinates. This function will return the coefficients of the regression lines, namely m and q. And this is the structure of the Python functions that we will write. This function will have 2 inputs, x and y, and 2 outputs, m and q. Now, what we need to do is simply fill in the dots. So this function will perform linear regression by computing the coefficients m and q according to this formula. And at a first glance, they might seem a bit overwhelming, but let's simplify them by breaking this task into smaller steps. First, we will compute the result of each sum, and then we will combine the results. And before we start implementing, it's worth noting that some of these sums are repeated more than once. For example, the sum of y appears twice and the sum of x even 3 times. Now we can take advantage of this and compute these terms only once and reuse them wherever needed. We're going to write a Python code to compute these 4 terms. These sums could be computed using for loops, but we are going to do it in a more concise and readable way by using the sum function from the NumPy library. This function allows us to compute directly the sum of all the elements in an array without using for loops. For example, mp.sumOfx calculates the sum of all the x coordinates. Similarly, np.sum of y calculates the sum of all the y's. To compute the last two terms instead, we need to introduce a new powerful concept in Python, vectorized operations. Let's consider the arrays x and y containing the element xi, yi respectively. The operation x star y creates a new array whose first entry is the product of the first entries of x and y, the second entry is the product of the second entries, and so on, all the way up to the last element. As a consequence, with np sum of x times y, we compute the sum of all the products, and we call this term sum xy. Similarly, the element-wise power operation x star star 2 is also vectorized, meaning that it applies the power operation to each element of the array individually. So that combining this operation with np-sum gives us the last term we need. Very good. Now the hardest part is behind us. We just need to combine these quantities together to finalize the computation. First, we compute the number of points, that is, the length of x, then the numerator of the expression of m, then the denominator. Then we divide the numerator by the denominator to obtain a value of m. And finally, we calculate q, making use of the value of m that we just determined. This completes the computations of the regression coefficients. Great, so we have completed the necessary step for the implementation of the function. Now that the function has been written, we can run this block of code and it's ready to be used. In this way, we are ready to apply it to our data set. We wonder how the temperature influences the fire weather index. To this goal, we choose the temperature as our x using this code. The label temperature extracts the corresponding column from the data set, and the attribute values returns the array. And similarly for the fire weather index, which becomes y. These two arrays are given as input to the linear regression function. The function returns two outputs that we store as two separate variables. And please note that the order of these outputs must match the order specified in the return statement of the function. Finally, we print the results, the regression coefficients m and q. In a print statement, by putting the f letter in front of a string, you allow Python to interpret the variable inside curly braces directly within the string. Running this cell in the notebook, we see the results printed on the screen. Let's now visualize the data points together with the regression line. By using the matplotlib module imported as plt, we create a new figure, and we use the function scatter to display the data points as small blue circles in the xy plane. Then we use the function plot to display the regression line in red. And finally, we can enhance the plot readability by adding axis labels, a title, a grid, and a legend. And please notice that the legend will depend on the labels we previously assigned to the data points and to the regression line. Running this cell, the plot is shown in the notebook. And we can see that the slope is positive, meaning that an increase in temperature corresponds to an overall higher risk of forest fires. Now let's repeat the procedure using the relative humidity instead of the temperature. And to do so, we simply replace the string temperature with RH in the previous lines of code. From the plot, we can see an opposite trend with respect to the previous case. This means that an increase in relative humidity decreases the overall risk of forest fires. Having in mind the initial question from the policymaker, we can conclude that temperature and humidity play opposite roles in determining the occurrence of forest fires. And understanding these relationships is crucial for an effective risk management. More in general, linear regression helped us to extract valuable insights from the data, enabling us to quantify the relationships between variables.